Okay, class, today we're in lesson 2.1, integer exponents. Lesson 2.1, integer exponents. Essential question: how can you develop and use the properties of integer exponents? How can you develop and use the properties of integer exponents? Okay, to help you better understand the lesson, we're going to pursue this Explore Activity 1, using patterns of integer exponents. The table below shows powers of 5, 4, and 3. 5 to the first power is equal to 5. 5 to the second power is equal to 25. Remember, 5 to the second power means 5 times 5, that's 25. 5 to the third power is equal to 125. That means 5 times 5 times 5. And 5 to the fourth power is equal to 625. That means 5 times 5 times 5 times 5. Hopefully I said that 4 times. But once again, that means 5 times 5 times 5 times 5. That equals 625. Now, based on this pattern that you see here, I'm going to answer 5 to the 0, 5 to the negative 1, and then 5 to the negative 2. And then you should be able to answer the questions for 4 and for 3. All right, here we go. 5 to the 0 power, that is equal to 1. 5 to the negative 1, I look at 5 to the 1 and I got an answer of 5. So 5 to the negative 1 means 1 over 5 to the 1. 5 to the negative 2, I look at 5 to the positive 2. Well, 5 to the positive 2 gave me 25. So therefore, 5 to the negative 2 is going to give me 1 over 5 to the 2, which equals 1 over 25. So the first thing I noticed then is that anything to the 0 power is always 1. Anything to the negative power, I'll put it over 1 and write the positive version of it. Over 1, positive version. That's the positive version, but it's over 1, so I'll move it down. Same thing here, 5 to the negative 2, I'll put a 1 over it and then write the positive version. 5 to the second power. Now, what is 5 to the second power? 25. And by the way, what is 5 to the first power? That's going to equal to 1 over 5. Okay, now based on the properties for 5, you should be able to do the properties for 4. 4 to the 0 power, that should be 1. 4 to the negative 1 should be rewritten as 1 over 4 to the 1. What is 4 to the 1 equal to? 4. So that's going to be 1 over 4. 4 to the negative 2, that's going to be rewritten as 1 over 4 to the positive 2, which equals 1 over 16. 4 to the second is 16. Same thing with 3. 3 to the 0 power is 1. 3 to the negative 1, I'm going to rewrite it as 1 over 3 to the positive 1. And then that's equal to 1 over 3, because 3 to the 1 is equal to 3. Next, I got 3 to the negative 2, and that's going to equal to 1 over 3 to the positive 2. So 1 over 3 to the positive 2, that's going to be 9. Okay, let's take a look at activity 2, exploring properties of integer exponents. A, complete the following equations. All right, we have 3 times 3 times 3 times 3 times 3. Well, what is that equal to? How many 3's do we see? 1, 2, 3, 4, 5. So it's going to be equal to 3 times 3. So 3 times 3 times 3 times 3 times 3 is equal to 3 to the 5th power. Let's look down here. We got 3 times 3 times 3 times 3. That's 4 3s. So it's going to be 3 to the 4th power. Times 3 to what? The 1 power. So how many 3's do I have altogether? 1, 2, 3, 4, and 5. So 3 to the 4th times 3 to the 1 is equal to 3 to the 5th. All right, let's look at the next set. Here, in parentheses, we got 3 times 3 times 3. So that's going to be 3 to the 3rd power. Here we got 3 times 3, so that's 2 3's. So it's going to be 3 to the 2nd power. How many 3's do we have altogether? 1, 2, 3, 4, 5. So we end up with 3 to the 5th. All right, now here's what you should notice. You have 3 different versions of 3 to the 5. 3 to the 5th from this version, 3 to the 5th from this version, and 3 to the 5th from this version. All right, the main thing you should notice is if my base is the same, 3 and 3, that means I have to add the exponents. If my base is the same, that means I have to add the exponents. So here I had a total of 5 3's, group 4, and then 1. What's 4 plus 1? 5. Here I had a group of 3 3's and a group of 2 3's. So what's 3 plus 2? 5. Once again, my base is 3. Anytime my base is the same, that means I can add the exponents. Okay, now based on that information, let's answer this question. Use your pattern to complete this equation. 5 to the 2nd times 5 to the 5th. 5 to the 2nd times 5 to the 5th. Well, there's no need for me to write out a group of 2 5's and then a group of 5 5's. I can simply just add because their bases are the same. 2 plus 5 is 7, and I have my answer. Now let's complete the following equation. Before we were working with multiplication. Now we're going to work with division. We got 4 to the 5th divided by 4 to the 3rd. 4 to the 5th means 4 times 4 times 4 times 4 times 4. That's 5 4's. 4 to the 3rd means 4 times 4 times 4. That'll be 3 4's. Now let's cancel out all the 4's that are alike. So that means I can cancel this out with that, cancel that with that, cancel that with that. All right, how many 4's do I have left? I have exactly 2 4's left. They did the same thing here. Cancel, cancel, cancel. I just want to show you directly using the color blue. All right, so now we have 2 4's left. So what does that equal to? 4 to the 2nd power. Now, of course, we don't have to write this out every time we get ready to do a problem involving exponents and division. So just like there's a shortcut for multiplication, there's also a shortcut for division. And this is the shortcut. If you got 4 to the 5th divided by 4 to the 3rd, then what you do is you subtract. What's 5 minus 3? That's going to be 2. So you end up with 4 to the 2nd. So in other words, this is a shortcut for this. This is a shortcut for all of this. This is a shortcut for all of this. So once again, the rule when you are multiplying is you add the powers. The rules for division, you subtract the powers. 2 plus 5 is 7. 5 minus 3 is 2. Okay, let's complete this problem. We got 6 to the 8th divided by 6 to the 3rd. We are dividing, our bases are the same, so therefore we subtract. What's 8 minus 3? That's going to be 5. Now that's way better than writing out 6 8s on top, and then, it's way better than writing out 8 6s on top, and then 3 6s on the bottom, cancel, 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 cancel all the way through, just to find out you have 5 6s left. It's way quicker to go 6 divided by, 6 to the 8th divided by 6 to the 3rd, 8 minus 3, 5, and you are finished. Okay, now we're going to teach you how to analyze a power raised to a power. Once again, we're going to teach you how to analyze a power raised to a power. So here we have 5 to the 3rd raised to the 2nd. Well, what does 5 to the 3rd mean? That means 5 times 5 times 5. But we're going to raise that to the 2nd power. Like so. So 5 to the 3rd raised to the 2nd means 5 times 5 times 5, parentheses, raised to the 2nd. Well, what does that mean? That means 5 times 5 times 5 twice. So let's write that out. 5 times 5 times 5, that's once, times 5 times 5 times 5. All right, so now how many 5s do we have altogether? 1, 2, 3, 4, 5, 6. So our final answer is 5 to the 6. Okay, now there's got to be a faster way to do this than having to write this out every single time. All right, so now what's the fast way? All we have to know is that when we're raising a power to a power, we simply multiply. What's 3 times 2? 6. So 5 to the 3rd raised to the 2nd equals 5 to the 6. Okay, so now let's apply this theory to this problem. We have 7 to the 2nd raised to the 4th. No need to write all of that out. No need to write out 7 squared raised to the 4th. All we got to do is we have a power raised to a power. What's 2 times 4? 8. And we are finished. Now, if we didn't know the rule to multiply, we would have to do this problem this way. 7 to the 2nd raised to the 4th. What does that mean? 7 to the 2nd means 7 times 7. 4 times. So 4 times. 7 times 7 once. 7 times 7 twice. 7 times 7 3 times. 7 times 7 4 times. All right, now how many 7s do we have altogether? 1, 2, 3, 4, 5, 6, 7, 8. So we end up with 7 to the 8th. Shortcut, and we learn this rule through practice. 2 times 4 is 8. And we're finished, as opposed to having to do all of this.